Contents of this video is taken from this book Power Systems Harmonics Fundamentals Analysis and Filter Design, Springer publication. This is written by George J. Wakil, and in these books I have already published one video on basic Fourier series. Today I'm going to start with the power factors, and when we start with the power factors, the first thing which is required is to calculate the power. So as far as power is concerned, there are three types of power. One is the active power, second is the reactive power, and third is the apparent power. And when you want to calculate distortion, then that time what you will do, distortion square is equal to apparent power square minus addition of p square plus q square. P is equal to active power square and q is reactive power square. So when you subtract it, you will get, when you will subtract active power and reactive power square from apparent power, then you will get distortion power. Now formula for the total harmonic distortion in case of voltage is equal to THDV is equal to square root of Vrms by V1 RMS square minus 1, where V1 RMS is nothing but the voltage of fundamental frequency, that is the lowest frequency. And similarly you can write the formula for total harmonic distortion in case of current. Vrms you can calculate Vrms voltage and current. You can write in terms of total harmonic distortion. When you write the formula, Vrms you will get is equal to V1 RMS square root of 1 plus total harmonic distortion square. And similarly, IRMS you will get in terms of total harmonic distortion. When you calculate IRMS upon I1 RMS or VRMS upon V1 RMS, then what you will get, square root of 1 plus THD square. So in case of voltage you will get 1 plus THD voltage bracket square, and in case of current you will get IRMS upon I1 RMS is equal to square root of 1 plus total harmonic distortion current square. Now here I'm going to define the active power and reactive power. The basic formula, when it is active power, V into I into cos theta, and reactive power, it is defined as V into I into sin theta. This is the basic definition. Here you can define in terms of RMS value of the harmonics. So the total active power in case total active power is equal to VHRMS, that is harmonic voltage, RMS harmonic voltage into harmonics voltage, that is current, and into cos of theta h minus phi h. So what is theta h? Theta is h is for voltage harmonics and phi h is the angle for current harmonics. So two different waveforms are there and their angle, that is angle theta h for voltage and angle phi h for current. Similarly, reactive power, it is defined as Vi sin theta. So here it is Vh Ih sin of theta h minus phi h, and here also the same thing. Theta h is defined as the angle in case of voltage waveform, and for the current it is phi h. Similarly, apparent power here defined as Vrms into Irms, and in terms of total harmonic distortion also it is written as S1, that is apparent power at the fundamental frequency, into 1 plus voltage total harmonic distortion square into 1 plus square root of 1 plus total harmonic distortion current square. So you can write the formula of apparent power in terms of total harmonic distortion. So in case of resistor, power dissipated is equal to V square by 2R. So here harmonic signals are there, and hence you can write the equation as 1 by 2R summation of Vh square, and H is equal to from 1, that is fundamental frequency, to all frequencies. That you can simplify as PR1 square. PR1 is PR1 is summation of H is equal to 1 and V harmonic square. So here PR1 is equal to power because of fundamental frequencies dissipated in resistor R1. Now in terms of current also you can write the basic formula is I square R. Here we required the total average power, so that is equal to I square R by 2. So here also you can write in terms of fundamental signal. So I1 square R divided by 2 into bracket 1 plus THD square. So in case of uh, uh, equation in terms of THD voltage, you can write as PR1 into bracket 1 plus THDV bracket square, and in case of current you can write PR1 into bracket 1 plus THD current square. In per unit form you can divide it by PR1, that is harmonic fundamental signal. So PR divided by PR1, that is equal to 1 plus THDV square, and in case of current you can write as 1 plus THD I square. Similarly, power in case of inductor is equal to, that is power, it is not dissipated power, it is the power stored. So power stored, that is the reactive power, is equal to 1 by 2 summation of VH into IH. So that is the average power, and V1 as you know it is XL into I1. So and XH is equal to VH is equal to XH into IH. So using that equation you can write VH by V1 and also QL by QL1. So QL1 is nothing but the reactive power for the fundamental frequency or the fundamental signal. So in case of inductor, it is the power absorbed by the inductor. In case of capacitor, it is power delivered by the capacitor, and hence the negative sign is there. So using that formula, you can find the reactive power. Here V1 is equal to I1 divided by J 2 pi F0C, because I1 into XC is equal to 1 by J omega C, and hence it is written in terms of current. So for V1, that is fundamental frequency voltage and harmonic voltage. Now here you can calculate the ratio VH by V1, and using that you can put the put the formula in the equation for QC by QC1. Hence you will get QC by QC1 is equal to, QC1 is nothing but a reactive power for uh, fundamental frequency, that is fundamental signal. So that is that QC by QC1 is equal to, that is the reactive power, the ratio of the reactive power QC and QC1 is equal to summation of H is equal to 1 H into VH by V1 bracket square, that is equal to summation of H is equal to 1 by H IH by I1 bracket square. So here the equation of the reactive power is written in terms of voltage ratio and in terms of current ratio. Harmonic studies are conducted to inspect the impacts of nonlinear devices and analyze certain harmonic situations. They are aimed at detecting resonance and calculating distortion factors. An impedance scan, that is also known as frequency scan, it is a plot of magnitude of driving impedance, that is the point impedance, at the bus of interest versus harmonic order or on or harmonic frequency, and is useful in identifying resonance condition. As you know, a dip occurring in the impedance value implies series resonance. Parallel resonance means what? It is identified as a sharp rise in the impedance value. A harmonic power flow, that is harmonic power flow study, uh, calculates fundamental and harmonic line currents and bus voltages. The outcome of different situation can finally be examined through the simulation of various filtering activities or filtering alternatives. I will Here I will stop this video, and in the next video we will start from the basic fundamental of series resonance and also how it is related to